Hey guys, Mr. Gucci here. This is your help video for your mini lab predicting dehydration. Now, for this mini lab, what I've done, this help video, is I'm basically going to walk through and do this entire lab on this video, but I'm going to use different numbers and, in fact, a different substance than you. You're using nickel 2 sulfate pentahydrate. You're using a nickel 2 sulfate hexahydrate. I'm using copper 2 sulfate pentahydrate. So, again, I'm going to walk through how to do this lab, but you will need to do it yourself because your numbers are going to be different and the substance itself is slightly different. All right, so let's get down to it, show you what we're going to do here. Okay, so first of all, we need to figure out, if we're working with copper 2 sulfate pentahydrate, we got to figure out what the formula is. Now, copper 2 is Cu with a 2 plus charge, okay? Now, sulfate is a polyatomic ion, SO4 with a 2 minus charge, all right? Now, crisscrossing this is actually going to be pretty easy. You don't even need to crisscross it. All right. Copper is 2 plus. Sulfate is 2 minus. Their charges cancel out, so you only need one of each. So this is CuSO4. Okay. CuSO4, one copper, one sulfate. All right. If you want to put this guy in like parentheses right here to remind you it's a copper and a sulfate, do so. That won't affect your results at all. Okay. But keep in mind, guys, that this stuff is also pentahydrate, which means it has a certain number of water molecules attached to it. How many? Well, what does the prefix penta mean? Think of the Pentagon, or if you worship Satan, a pentagram. All right, go down one of those many tattoo parlors, that you have around town. Probably you can get a pentagram tattoo. How many sides does this have? 5. Okay, so pentahydrate is 5 H2Os. So that is the formula of this substance. CuSO4, 5 H2O. So that's step 1. All right, that's first problem. Next part is we have to come up with the percent composition of all the parts of CuSO4. 5H2O. What percent is copper? What percent is sulfur? What percent is oxygen? And what percent is water? Okay, so here we go. Let's figure it out. Okay, now the first step here is going to be to figure out what is the total molar mass of the whole thing. So we have one copper. So we got to figure out what's the mass of a single copper. A single copper is 63.55. So it's going to be 63.55. All right, let me make this a little bit smaller too. Otherwise, I won't have room for it. All right, it's also made of one sulfur. One sulfur. So sulfur is 32.07. It's made up of 4 oxygen. So that's going to be 4 times 16.00 plus 5 H2O. So plus 5, and I know for a fact that H2O is 18.02 grams per mole. So what is the molar mass of copper 2 sulfate pentahydrate? Well, it is a copper plus a sulfur plus 4 oxygens plus 5 H2Os. Now that I type this all out, I can just paste this into Google. And it tells you the molar mass is 249.72 grams per mole. 249.72 grams per mole. All right, an important number here, something to keep an eye on. We're going to use this in the next portion, where we have to figure out what percentage of the substance is copper, what percent is sulfur, and what percent is oxygen. So, the percentage called copper. Now, whenever you're trying to find a percentage, it's always the part divided by the whole. So, what part of this is copper? Well, there's only one copper here. So it's going to be a mass of one copper divided by the mass of the whole thing. It's the mass of the copper divided by the mass of the whole thing. Let me shrink that down a little bit. All right, cool, 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 cool. Let me shrink a little bit more. Great. Okay. So the mass of a copper is 63.55 grams per mole. The mass of the whole thing is 249.72. 249.72 grams per mole. All right, again, this is the copper. This substance only has one copper in it. It only has one copper in it. Okay, so when you're figuring out the percentage, okay, it's going to be the single copper, because there's only one of them, divided by the molar mass of the entire thing. Okay, so it's just the mass of a single copper divided by the molar mass of the entire thing. Okay, so I'm just going to put this into Google, see what I get. I get 0.254. 0.254. So this stuff is 0.254 copper, or bounce that decimal place over twice, 25.4% copper. Now again, this is my sample problem. I do not want to see copper come up in any of your labs that you turn in, because you were not doing copper, you were doing nickel 2 sulfate hexahydrate, okay? But for the copper, it's going to be this, all right? How about the sulfur? Once again, it's the part divided by the whole. This substance has only one sulfur in it. Only one sulfur in it, okay? Which has a mass of 32.07. Okay, so when you're trying to figure out what percentage of this is sulfur, it's going to be a single sulfur divided by the whole thing. Okay, it's going to be the mass of a single sulfur divided by the mass of the entire compound. So a single sulfur is, again, 32.07. Okay, divided by the mass of the whole thing. So divided by 249.72. All right. And what is that equal to? Well, let's plug that in to Google. I've already typed it out. This isn't cheating. I'm just using Google as a calculator. 0.1284 or 0.128. All right. 0.128. 0.128. Or as a percent, 12.8% sulfur. What about the oxygen? Now, again, the percentage oxygen is whatever part of this is oxygen divided by the whole mass. Now listen, this substance had one copper, so we only used the mass of a single copper here. Okay. It had one sulfur, so we only used the mass of a single sulfur here. But this substance has four oxygens. Four oxygens, okay? Four of them. Four. So in this case, to find the percentage oxygen, we need four oxygens divided by the whole thing, right? The mass of four oxygens divided by the whole thing. Let me see if I can shrink this up and make it all fit. Cool, 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 cool. All right. Well, what's the mass of four oxygens? That's going to be 4 times 16 divided by the total molar mass, which is, as always, 249.72. All right. I'm going to plug that into Google again and see what I get. This stuff is 25.6%. So 0.256. All right, so 0.256, which as a percent is 25.6%. That this is 25.4, this 25.6 is purely coincidental, okay? Just a coincidence that they're so similar, okay? Lastly, the H2O, okay? Once again, we're looking for the part of this that is H2O divided by the entire molar mass. Now, just like there were four oxygens here, this substance contains five H2Os. Five H2Os, okay? So, this is going to be the mass of five H2Os divided by the mass of the whole thing. all right, divided by the mass of the whole thing, all right? That's too much to put into one line, so we'll just let it be, okay? So 5 H2Os divided by the mass of the whole thing. So what is that going to be? Let's see here. I'm going to copy this in there, save myself some time. So 5 H2Os, so that's 5 times the molar mass of H2O, so 18.02, divided by 249.72. What do we get? 0.3608. So 0.361. Okay, so 0.361, which as a percentage is 36.1% H2O. So this substance is 36.1% H2O. This, by the way, this area right here, this is the most important information in this question right here, okay? Because you need the percentage H2O to move further on in this lab, okay? I'm a stickler for color coding. Got to make sure it's all color coded. All right, cool. So, on to the next question. As a class, we recorded a starting mass of your hydrate. We put it on a scale, we weighed it, and we recorded it, okay? We recorded it. Every class was different, but in most cases, it was around 10 to 15 grams. So I'll just use a sample here, all right? This is not what you had, all right? So let's say 12.45 grams, all right? This is an example. This is not your number. Okay, I wrote your number on, I think, the lab when I uploaded it. Like on the assignment, I think we put what the class's number was. Okay, so listen, here we go. So we weighed some out on a scale, somewhere between 10 and 15 grams of this stuff. So based on your answer to number 2 and your answer to number 3, I want you to predict what mass of this sample is water. What amount of this sample is made of water? So that when I heat up this sample of copper 2 sulfate pentahydrate, how much water will be removed? Well, check this out. All you need to do is take your starting mass, which is 12.45 grams in my case, and multiply it by the percentage water that this is. This is 36.1% water. So 12.45 grams times 36.1% equals, we'll copy, let's see. This stuff was about 4.49 grams of water. So we had about 4.49 grams of H2O in this sample. Okay, very good. Now, this was your prediction about how many grams of water our class sample had in it. Okay, we predicted, we theorized it'd be 4.49 grams. When we try this in the laboratory, how many grams of water were we able to remove? All right, well, let's take a look here. Let's take a look. This is another example of we would take our sample of copper 2 sulfate pentahydrate. And by the way, here's what this stuff looks like. It looks like some bluish colored sand. Now, when you heat this stuff up, all right, over a Bunsen burner, and I managed to bring in a little flame source, it turns from this blue crystal to a white powder. Okay, this blue crystal is copper 2 sulfate with the water molecules attached. And when you heat it up, it turns into copper 2 sulfate by itself. No water molecules attached. You can see how it also kind of like shrinks down a little bit. It shrinks down that way. It looks different because this substance no longer has any waters. By heating this up, you evaporated out all the water molecules that were attached to it. So this is CuSO4 5H2O. This is just CuSO4. All the H2Os are gone. And so we'd measure this, and let's say we measure it and we find that it has a mass of 8.31 grams. All right, 8.31 grams remaining. All right, so how much water, how much did the mass of this substance go down? Well, we started with 12.45 grams. We ended with 8.32 grams. So what we lost here was 4.13. So what we got here is 4.13 grams H2O lost. Okay? Now look, you predicted, well, in this case, I predicted, based on my calculations, that we should be able to remove 4.49 grams of H2O. When I tried to run the experiment, I was only able to remove 4.13 grams of H2O. So what was my percent error here? All right, well, the percent error is what you predicted minus what you got in the experiment divided by what you predicted. All right, and that can't be a negative number. You got to make it a percent. So here I go. Here I go. All right, I predicted 4.49 grams lost. I actually lost 4.13 grams. Okay? And I divide that by what I predicted. All right? What I predicted. And what we predicted was a number 4.49. All right? So what does that equal? What does that equal? Let's see. Again, if you type it down, you can just paste it into Google. Google becomes your calculator. So 0.080. Okay, so what we got here is 0.080. That's equal to, bounce this decimal over twice, 8.0% error. So in our case, the error here was 8.0%. Okay, so we predicted, hypothetically, we should have lost 4.49 grams of H2O. When we ran the experiment, we could only remove 4.35 grams of H2O by heating it up. The percent error was an 8% error. Yours might be higher. Yours might be lower. By the way, if you get a negative number, like if I switch, like if it was negative 0.080, all right, you can't have a negative percent error. Remember, this is an absolute value. So whatever you get, if it's a negative, you just got to make it into a positive. Okay, you just got to make it into a positive. So this was 8% error here. Now you got one last question here, okay? Hypothesize. What do you think caused Mr. Gucci's error? Now, if we removed hypothetically more water than we predicted, what might have been the error here? All right, that's not what we got here. We predicted we would remove 4.49 grams of H2O. We only removed 4.13 grams of H2O. So what do you think caused that? Why was I unable to remove all the H2O? Hypothesize what caused the error. I think one class doesn't have question 7 on their lab. You guys can skip it. But I know that 2 classes do. So if you have question 7 on your lab, you just got to run it. Go through it and try and just, there's no wrong answer here. All right. Well, there's not many wrong answers. Just hypothesize. What caused Mr. Gucci's error? Think of something, let me know, and we'll rate it, and we'll talk about it when we finish up this lab. All right, guys, that's it for this lab. All right, thank you very much. Have a good day.